Hi students, this is AJ sir. Let's study 9th standard ICSE Math chapter 1, rational and irrational numbers. Let's understand the meaning of these two types of numbers. We know that whole numbers are those which start from 0 and go on till infinity. They don't contain any decimal values. If you remove the 0 from this set, then the set of the remaining numbers, that is the positive integers, are called naturals. So the positive integers, the negative integers and 0 together form a set called integers. That is from minus infinity to plus infinity, but it does not include any decimal values. So if we include the decimal numbers as well, positive as well as negative, together they are called rational numbers. So rational numbers are all the numbers which can be expressed as a fraction. Minus 8 is a rational number, even that is a fraction, minus 8 upon 1. But there are some numbers which are irrational, whose decimal answer, exact decimal answer, is unknown. For example, square root of 2. If you try to calculate the square root of 2 by the long division method or by using a calculator, you will see that the decimal value is non-terminating and non-recurring. The digits just go on for infinite number of decimal places. You don't see any pattern in it. That means it is not recurring. And the remainder will never come 0. That means it is non-terminating. Such numbers cannot be expressed in the fraction form like this. It may have a root sign, cube roots, fourth roots, and even some numbers which are not roots and still irrational, like pi. We don't know the exact value of pi. 22 upon 7 or 3.14 are just approximations. The exact value is unknown because it's 3.1415 and it goes on till infinity. It never stops. Even if you use a supercomputer, the entire screen will be filled up with decimal digits. But it will not be recurring nor terminating. Such numbers are called irrational numbers. And rational and irrational numbers together are called real numbers. That means all the numbers we deal with in math, school level math, are called real numbers. There are some numbers which are not real. They are imaginary. For example, square root of minus 5. That's an imaginary number. We don't use such numbers in school level. You can't calculate at all. Try it in a calculator, it'll give you an error. How can a square root of a negative number be found? It's impossible. Now exercise 1A is cancelled and even the solved examples are cancelled. Now before we start with 1B, remember a few rules, so just tick it so that you know that you have to revise this also whenever a test is conducted for this chapter. You cannot add two square roots. That means root 3 plus root 5 cannot be root 8. Yeah, if both the terms are like terms, like root 5 plus root 5, then you can write 2 root 5. It's similar to saying a plus a gives 2a. Multiplication is always possible between roots if both of them have the same umbrella, that is both of them are square roots or both of them have cube roots. So root 5 into root 5 is actually root 5 into 5, root 25, and root 25 is 5. So remember, root 5 into root 5 is 5, or you can say root 3 into root 3 is 3, or root 2 into root 2 is 2. Now here, 5 upon root 5, you can reduce it further. You see, either you can rationalize the denominator into root 5, up and down. Now root 5 into root 5 is 5. So cut 5 and 5. So what is left is root 5. So that's what is mentioned here. That is true for all of this. Under the umbrella, if you see a big number, you can simplify it. You must simplify it in numericals. So first do prime factorization. And now since there is a square root sign, so remove the groups of 2 out. So this will come out as a single 2. This will also come out of the umbrella as a single 2. So the only number left under the umbrella is 3. So the answer is 4 root 3. Next, we have plotting of number lines for irrational numbers. We need to remember all these examples, and we shall study how to draw them when we come to that question in the exercise. Now, how to prove that root 2 is an irrational number? There is an alternative method which is a more mathematically accurate method, but it's a bit complex, so I'm going to show you an easy method. We will use the long division method. Now in this method, we will find the square root up till 6 or 7 decimals, and we can see that the decimals are non-repeating and non-recurring, and they're non-terminating because the remainder is never 0. Hence, we can assume that it is an irrational number. This is not a perfect proof, but it gives us an idea about why root 2, root 3 and root 5 is irrational. Now let's see how to do long division method. So we put some decimal values and we put them in groups of 2 each. We start with a number here, 1, and whatever number we write here should be written here as well, such that the product of the 2 is less than or equal to it, but not more than that. Then we write the remainder, and then the entire group comes down. Then we write one more digit here and the same digit here. 24 4s are 96. 4 is a remainder, then 2 zeros come down. Now whatever number we wrote here, add it to that last digit. So 24 plus 4 is 28. Now again write a third digit here and write the same digit here, and the process goes on. Let me do one such sum for better understanding. Let me solve root 3. So I have to find the square root of 3. Let me put some decimal places. Let's go up till 4 decimal places. I'll just group them. Here I have only one digit before the decimal place, so just one number in this group. If it was 13, then that would be totally one group. Now 2 2s is 4, that is too big a number. So let me write here 1 1s are 1. So the remainder is 2. This comes down, becomes 0 0, decimal above decimal. Now I wrote 1 here, so let me add 1 here. So that becomes 2. Now fill in the blanks, 1 blank here and 1 blank here. Put a digit here and here, same number, such that their product is 200 or less. It seems it is 27 into 7. 27 into 7 is 189. I'm sorry. So the remainder is 11 and carry forward 0 0. And whatever number we added here, it becomes plus 7. So this becomes 34. Now again fill in the blanks. Put one digit here and the same digit here such that their product is 1100 or less. Let's put a 3 out here. So that becomes 1029. And the remainder is 71. Carry down 0 0. Always the group, entire group comes down, not just one digit. 2 digits come down. Now we had added 3 here, so The next number is 3, 4, 6. Fill in the blanks. One number here and same digit here, such that the product is 7100 or less. So we have to actually try it out in rough work to find out which number will be the best suit. 3462 into 2 will give you 6924. If I put a 3 out here and a 3 out here, then the multiplication will give me a number bigger than 7100, so that cannot be used, and the remainder is something. And so this process will go on 1.732 050, and will go on till infinity. We will never be able to get a final answer, hence they are called irrational numbers. Now cancel this. Solve example number 3, solve example number 4. Take this note. Remember that if root x is greater than root y, then squaring both the sides, we can conclude x is greater than y. Also, if let's say 5 minus a root 3 is equal to b minus 2 root 3, they are of the same format. So we can conclude that 5 is equal to b and minus a is equal to minus 2, minus minus cut, we can say a is equal to 2. Also remember, the negative of an irrational number is always irrational. The sum of a rational and irrational number will always be irrational. For example, 2 plus root 3 is totally an irrational number. The product of a non-zero rational number and an irrational number is always irrational. For example, if you multiply this and this, there are two irrational numbers. Their product can be rational. But if you multiply this and this, which are two irrational numbers, interestingly, their product is also an irrational number. Here we can do distributive multiplication. More examples. The sum of irrational numbers can be rational. For example, here root 7 minus root 7 got cancelled. So we got a rational answer. That is true for subtraction as well. And also when you divide irrational number by another irrational number, we may get a rational answer, because here root 3 cancelled with root 75 to give you a rational answer. The solved examples are for homework. Now in exercise 1b, there are some cancellations. Question 6 is entirely cancelled. Question 7 is cancelled. Question 8 is cancelled. Question 9, 10, 11, 12 are cancelled. 13.3 is cancelled. 16th is cancelled. And 19th is cancelled. The sums which are ticked I will be doing in the video, and the remaining sums will be for homework. Now mark some IMPs. There is only one IMP question in this exercise. That is the 15.1 question. Now in exercise 1b, question number 1, Roman number 1, Roman number 3 and Roman number 5 are the sums we are going to do right now. We will simplify them, that is solve them, to find out if they are rational or not. At first look, I can see that all of them have the square root sign, that is the umbrella. So it looks like an irrational number, but let's be sure about it. In Roman number 1, this is of the format a plus b the whole square. So we use the formula a square plus b square plus 2ab. This becomes 4. Root 2 square is nothing but 2. Root 2 into root 2 is 2. You can also think of it like this. Square root and square gets cancelled. 2 into 2, 4. 4 into root 2, we can't do anything about that. It is 4 root 2. So the answer is 6 plus 4 root 2. We can't add them. They are unlike terms. It's like 6 plus 4a. So here I see a root sign still remains. So totally I call this an irrational number. Now in Roman number 3, it is of the format a plus b, a minus b, because I see that the first terms are same and the second terms are same, only the sign between them are different in the brackets. And the formula for this is a square minus b square. That is totally different from a minus b the whole square. So here a squared minus b squared, and if I solve it, I get a rational number. Now in Roman number 5, squaring both the sides, the numerator is squared and the denominator is also squared. 2 square is 4 and root 2 square is 2. Multiply them, we get this. There is no root sign here, so it's a rational number. Next, in question 2, find the square of. Let's do Roman number 1 and Roman number 3. Just like we did in the previous sums. In 2.1, we square the numerator, so 3 square becomes 9. Root 5 squared becomes 5. And denominator 5 square becomes 25. We simplify it. Roman number 3, this is of the form a minus b the whole squared. And what's the formula for that? A square plus b square minus 2ab. This becomes 5, this becomes 4. 2 into 2 is 4, root 5 remains as it is. So we get this as the answer. Now question 3 is true or false. So you need to write the answers in the tuition book, numericals book. Roman number 1, root 2 plus root 3 is equal to root 5, false. We can't add them like this. Roman number 2, is 2 root 4 plus 2 is equal to 6? Let's think about this. Root 4 is actually 2. 2 into 2 is 4. And 4 plus 2 is 6. So this is actually true. Now Roman number 3, 3 root 7 minus 2 root 7 is equal to root 7. Yes, this is true. If it were 3a minus 2a, that would be is equal to 1a. Similarly, 3 root 7 minus 2 root 7 is 1 root 7. So this is true. Roman number 4, is this an irrational number? No, it is not. If you divide it, yes, it is non-terminating, but it is recurring. So it is a rational number. 5 upon 11, is it a rational number? Yes, it is. All rational numbers are real numbers. True. And all real numbers are rational numbers. False. Because real numbers may also be irrational. Some real numbers are rational numbers. True. The next question is, in this question there are many numbers given. We have to classify them as rational, irrational, integer and non-negative integers. So the solution is given here. Set of rational numbers, set of irrational integers and non-negative integers. A number may be a part of more than one groups as well. Rational numbers, all of them are rational, all of them. The only irrational numbers are root 8 and pi, because root 8's value we don't know exactly and pi's value also we don't know exactly. So all other numbers are rational, only 2 are irrational. Now out of all these rational numbers, a few of them are integers. Whichever number is not a decimal or a fraction, it is an integer, be it positive or negative. So we have these integers, negative, positive and even 0. Minus root 4, yeah, minus is outside the root, and root 4 is actually 2, so this is actually minus 2. What about non-negative integers? Non-negative integers means whole numbers, which we have as 0 and 1. Now question number 5 is represent each of the following on different number lines. We have totally 5 questions: 2 root 3, 2 root 2, 3 plus root 2, 3 minus root 2 and 2 root 5. I'm going to do the first, third and fifth sum, and the remaining you can do on your own. You may even refer to the solved theory part on page 6 and page 7 for a revision on this. So let's first draw 2 root 3. Now we know how to draw a number line of integers. So let's start with that. You have to use a pencil and ruler. I'm using a pen for better visibility. Let's take it as 0, 1 centimeter, 2 centimeter, 3 centimeters, 4 centimeters. Should be enough. And the left hand side, I'll just take 2 more points. So this is 0, 1, 2, 3, 4, minus 1, minus 2. That's your usual number line. Now I need to plot 2 root 3. First, let me plot root 3. Now remember, for plotting root 3, first I'll have to plot root 2. How to do that? Now take 1 centimeter as a base, 0 to 1, 1 centimeter, and draw a perpendicular of 1 centimeter. Now all of us know how to draw a perpendicular with the help of a rounder. Use rounder and pencil to do the needful. Draw a perpendicular to this. Now on this, mark 1 centimeter exactly. Let's say this. And now join 0 with that point. So now I got a triangle with base as 1 centimeter and height as 1 centimeter. Now if you notice, in a triangle, if my base is 1 and height is 1, I can find the hypotenuse using Pythagoras theorem because it's a right angle triangle. And let the hypotenuse be x. So Pythagoras theorem says that the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the other two sides, is equal to 1 plus 1, 2, x squared. So square goes on the other side and becomes square root of 2. This means that this hypotenuse x is nothing but square root of 2, which is approximately 1.414. It's an irrational number, by the way. So now let me take the measurement of the hypotenuse with the help of this compass, and here we go. So that means this point, this distance between 0 and this point is actually the same as the distance between 0 and this point. So let me mark this as square root of 2. So now you know how to plot square root of 2 on the number line, whose value is approximately 1.41. So you should confirm this with the ruler. Yep, it is 1.4. But we wanted to draw root 3. So at this point, root 2, again draw a perpendicular. Now for simplicity's sake, I'm just going to draw it straight away with the ruler, but you shouldn't. And take 1 centimeter on it with the ruler. Now let's draw the hypotenuse of that triangle, a new triangle. So that's a new triangle. Let's calculate what will be the hypotenuse of the new triangle. In the new triangle, I've got the base as root 2. Yeah, the base is root 2. And the height as 1 centimeter. Let the hypotenuse be x. So by Pythagoras theorem, I get x squared is equal to root 2 squared plus 1 squared. Root 2 square is 2 plus 1 is equal to 3. That means x is equal to square root of 3. That means that this hypotenuse x is actually square root of 3. So with the help of this compass, let me just mark it So that means that the distance between 0 and this is the same as the distance of this hypotenuse. So this point is root 3, which is 1.732. If you measure it with ruler, it will be 1.732. But they want to plot 2 root 3. Not root 3, but twice of root 3. Well, that's easy, because if this is root 3, then just double it from here, again mark root 3. So if this much distance is root 3 and this much distance is root 3, totally this distance is 2 root 3. So let's plot this as 2 root 3. So that's your final answer. Now let's plot 3 minus root 2. We know how to plot root 2, but they want 3 minus root 2. Now just roughly, if I check, 3 minus root 2 will be around 3 minus 1.4, which comes up to 1.6. So I get a brief idea that the final spot should be between 1 and 2. So we draw a number line as usual. You should use proper measurements, though I am not. So we'll start with 3. Minus means towards the left, and addition would have meant towards the right. 3 minus root 2. So we take a base of 1 centimeter and we'll draw a perpendicular. Perpendicular should be drawn with the help of compass only, although I am not. And take 1 centimeter with the help of a ruler. So in this triangle, this right angle triangle has a base of 1 centimeter and a height of 1 centimeter. That means the hypotenuse is root 2. So with the help of compass, let me mark root 2 on the left hand side, because it's subtraction. What this means is the distance between this point and this point is around 1.414, which is root 2. So from 0 to 3, that's 3 centimeters, and minus root 2, this is the final answer. And indeed, as I said, it should be between 1 and 2, which is what it is. Measure it with the ruler, it should come out to be around 1.6. So let's mark this as 3 minus root 2. If it was positive, we would have done everything on the right hand side. The base would be between 3 and 4, and the height out here, and the marking would be around 4.4. Next, let's do 2 root 5. So for 2 root 5, we'll first plot root 5 and then we'll double it. Root 5 will be 2 point something. Now again, you should use proper measurements. Here we will take the base as 2 centimeters and the height as 1 centimeter. Let's draw the hypotenuse here. Because in a triangle, if the base is 2 centimeters and the height is 1 centimeter, then how much is the hypotenuse? As per Pythagoras theorem, x square is equal to 2 square plus 1 square is equal to 4 plus 1 is equal to 5. So x is equal to root 5. So this hypotenuse is root 5. So with the help of the compass, let's plot root 5. Sorry. So this point is root 5, but they want the double of root 5. So we'll measure it with the compass and the same measurement forward. This is the final answer. This is 2 root 5. Now in question 13.1, which is write in ascending order, or rather just mention which is bigger and which is smaller, you have to compare 3 root 5 and 4 root 3. Now it's difficult to find out which one is bigger because this one has root 5 and this one has root 3. And we have numbers 3 and 4 outside the umbrella. So what we'll do is we'll shift these numbers inside the umbrella like this. Now we know that under the umbrella, if we have 3 into 3, then the group of 2 3's will come out and become a single 3. That is square root of 9 is equal to 3. Let's send 3 under the umbrella. Let's do the reverse. So that will become 3 into 3 into 5. You see what is square root of 9? It is 3. So the value is same. Similarly, let's shift 4 inside the umbrella. So it will become 4 into 4 into 3. The reason why we are doing this is because now we have 9 into 5, 45. And here we have 16 into 3, 48. Now it's easy to compare them. 48 is definitely bigger. And when they say arrange in ascending order, it is already in the ascending order. Now in question 15.1, which says compare, again the challenge here is that this is the 14.1, the challenge is here is there is a 2 outside and then there is a 3 outside. Let's shift the numbers inside. So since there is a 4th root, when we shift this 2 inside the umbrella, we'll have to write 2 4 times. And even when we shift 3 inside, we'll have to write it 4 times. So this becomes 4th root of 96 and this becomes 4th root of 162. So now it's easy to compare. We discover that this is greater. So write the final answer where you use the values given in the question. 3 into 4th root of 2 is greater than 2 into 4th root of 6. Now in question 15.1, we have to compare. Now the challenge here is that this is a 6th root and this is a 4th root. We would like both the root signs should be exactly same. Then only we can say which is greater and which is smaller. So here what we'll do is we will remove the LCM of 6 and 4, which is 12. So we will do into 2 outside and raised to 2 inside. And here we'll do into 3 to the outside root sign and raised to 3 inside, which is the same thing because 3 and 3 will get cut. By doing this, now the root signs are 12 and 12, and the inside numbers give us an idea about which is bigger and which is smaller. Clearly, the 4th root of 12 is bigger than the 6th root of 15. Now in the 17th sum, insert 5 irrational numbers between these two irrational numbers. First of all, we shall send 2 and 3 inside the umbrella like we did in previous sums. And now it becomes easy to insert irrational numbers in between. Root 21, root 22, root 23, root 24 and root 26. Root 25 is not irrational because that is 5. That is rational. Now in the question 20.2, simplify the following. What we'll do here is, first of all, let's have a common umbrella for numerator and denominator because it's the same 4th root for both of them. And then we'll reduce them. 3 ones are, 3 81s are. And always remove the prime factors. Now since it's a 4th root, we'll remove the group of 4 out of the umbrella. So nothing is remaining under the umbrella. The answer is 3. And in 20.4, which is root 3 minus root 2 the whole squared, we will use the formula a square plus b square minus 2ab. So a square becomes 3, b square becomes 2, and minus 2ab, root 3 into root 2 is root 6. We can't do anything with 2. And this is the final answer. We can't simplify this further. We can't take out anything common. So this is the answer.